When you're computing the least common multiple of two relatively small numbers, the easiest way to do it is usually to just list out the multiples of the numbers and just keep listing out multiples until you find a multiple that is in both lists. Find a number that's in both lists. Okay, so 24 is a multiple of both 6 and 8, and it's the smallest number that appears in both lists, and so this is the least common multiple. Now, let's say that we had a more complicated example. Let's use the two numbers from the previous video, 124 and 280. What is the least common multiple of these two numbers? Well, to me, one of the easiest ways to go about doing this one I would not want to list out multiples. That would be really tedious, and I don't know how long that would take, probably a while. What I would do instead is get the prime factorizations, because if you have the prime factorizations, it helps a lot. So 124 is equal to 2 squared times 31, and 280 is equal to 2 cubed times 5 times 7. So these are their prime factorizations. 2 squared times 31, 2 cubed times 5 times 7. Okay, what do we do with this? Well, from here, let me do a slightly simpler example. What's the least common multiple of 2 squared and 2 cubed? Okay, well, 2 squared is a it is a multiple. Sorry, it's a factor of 2 cubed. So 2 cubed is a multiple of 2 squared, right? So 2 cubed is a multiple of 2 squared. It's this times 2, right? And so it's also a multiple of itself. So 2 cubed is the least common multiple. And that would be the same if this was just like 2 to the first or whatever. And if this was maybe 2 to the fourth and 2 to the seventh, the least common multiple would be 2 to the seventh, because I could just multiply this by 2 cubed to get to 2 to the seventh. Okay, so keep that example in mind when I say what I'm about to say. If I start introducing more factors into all of this, the least common multiple is going to we're just going to kind of do that for each of the factors. So the least common multiple of 2 squared and 2 cubed is 2 cubed. There's no factors of 5 here, but we need to have 5 in our number, right? It has to be a multiple of 5 because it is a multiple of this number. It also has to be a multiple of 7 because it's a multiple of this whole number. There's no factors of 7 here. And then we'll also have to have a 31 right here. Okay, so this right here is the prime factorization of the least common multiple of 124 and 280. Let me do another similar example. Let's say that we had the prime factorizations were, say, 2 squared times 5 cubed times 7, and let's say 2 to the fourth times 3 squared times 5, just like that. Okay, what would the least common multiple here be? So I recommend pausing the video and seeing if you know how to answer this. We'll give you a couple seconds to pause and then I'll discuss. Okay, so 2 squared and 2 to the fourth, I need to just kind of pick the bigger exponent between the two. So 2 to the fourth. Okay, what about powers of 3? So it has to be a multiple of 3 squared because it's a multiple of that number. There's no 3's over here, so I just need to have a 3 squared. 5 cubed versus 5 to the first. It has to be a multiple of 5 cubed and a multiple of 5. So let's pick the bigger one, so 5 cubed. And then 7 is the last prime that appears here, so I'll just put a 7 here, 7 to the first, because there's no 7s in the second number here. Okay, so this is our least common multiple. So you can really just look at all the prime factors between the two numbers and just pick the larger exponent for each of the prime factors, okay, and make sure that you're not missing any of the prime factors. This is very similar to what we did when we were doing the GCD of prime factorizations. With GCDs, what we did was we get our prime factorizations and then we just pick the smallest of the exponents for each factors. So here we'd have like 2 squared. We wouldn't have any 3's in here. Like the smaller exponent for like the prime factor of 3 is basically 0, because this is like, there's like a 3 to the 0 over here. And then we would do times 5 to the first, and then we wouldn't have any 7's here. Okay. Good. So, what else can we kind of observe here? Well, if we were to, one thing that we can say is if you were to multiply these two numbers together and multiply these two numbers together, you would expect to get the same thing. Okay. Why is that? Well, if I just do it for like one prime at a time, so here, if I'm just looking at the 2's, the GCD is going to have the smaller exponent and the LCM is going to have the bigger exponent, right? Similar for like the 5's, the LCM is going to have the bigger exponent and the GCD is going to have the smaller exponent. And the same is even true for things that do not appear in both numbers. So like 7 to the 0 is like over here. Technically there's a 7 to the 0 over here as well. So the LCM is going to have the bigger exponent and the GCD has the smaller one, which here the smaller one is 0. You could even just kind of say that the GCD just doesn't have it, whereas it doesn't like show up over here. So when you multiply the LCM and the GCD, you are effectively just like multiplying the same prime numbers for each of them, and so you get the following fact: A times B is equal to the GCD of A and B times the LCM of A and B. And this is often written in a variety of ways. One of the common ways of writing this is that the LCM of A and B is equal to A times B over the GCD. And why would we bother writing it like this way? Well, because if you know the GCD of two numbers, which we have kind of more tools for computing the GCD than we do for computing the LCM, so sometimes it is pretty easy to just see what the GCD is going to be of two numbers. So if you know the GCD, then to get the least common multiple, you can basically just use this formula. Just multiply your two numbers and divide by the GCD. So for example, what is the least common multiple of 56 and 57? So the GCD of 56 and 57 is 1. Why is it 1? Well, similar to like the previous video, you can subtract the smaller number from the bigger number and say that this is the same as the GCD of 56 and 1, subtracting 56 away from 57. All right, what's the GCD of any number with 1? Well, 1 is the only divisor of 1, and so it's a divisor of 56 as well, so that's the biggest common divisor. So the GCD of these two numbers is 1, and so the LCM is going to be equal to 56 times 57 divided by the GCD, which is just 1, so we don't even have to do anything there. And so it's just whatever that product is. I'm not going to compute it. You could use a calculator if you particularly care to know. But that's just what the least common multiple is. We don't have to do much work. We don't have to like list out all of the multiples. If you did, you would have to list out 57 numbers or 57 multiples of 56, and you would have to list out 56 multiples of 57, and it would just get really time consuming, really annoying. You could also find the prime factorizations of these two numbers. That would probably not be too bad in this example, but if you had the LCM of like, say, 256 and 257, that would be a little bit more tedious to do, right? But you could do it in the same way. The LCM is still going to be equal to, the GCD is still going to be equal to 1, but the LCM will just be equal to the product of those two numbers, right? So this is a pretty useful fact to sort of have in your back pocket.